for Modbus TCP Server. When the application is first started, we can see this window, and we'll just go through a bit of an explanation of all the different elements on it. This first video is only intended as a getting started video, so we've got a few more videos after that that explain some of the details. So firstly, in this window we can see this part here, which describes the TCP side, the Ethernet side. This part here, which is used for simulating various errors and for diagnostics. And then we've got this part down here, which is the actual registers which are stored on the server. So let's just go through the configuration in Preferences. In Preferences, we have got a couple of tabs. One is for Modbus, one is for TCP. TCP, very simple, there's only a port number. This is the port number that the TCP server is running on. 502 is the standard Modbus port number, but you can change that here to any other port that you like. The Modbus configuration, well, one of the things that we have when Modbus TCP Server is started, it doesn't contain any registers at all. So there's a number of different ways of adding registers. One is by using the button, the add button here. But the other one is to automatically add them, so that when a request is received from a TCP client, we can make the server automatically add those registers. For that, we have got two tick boxes here. So one is on read. So when there's a read function, that is the client will try and read a register from the server. If that register doesn't exist, with this box ticked, it'll automatically add that register. The other one is on a write function. If it's writing a register, we can just add that register automatically in here. Then we've also got the default register values. When Modbus TCP Server automatically creates a value, a register, this is the value that's assigned to it. And we've also got a title prefix. So this column here, which is the title column, will have this prefix on it. You can modify and change that as you see fit. Here we have got a debug log, the startup info, and the data log timestamp. You'll see some of those later on, what they do. So with the preferences set, TCP set to 502, we are ready and we can start our server. Now we can see that the server is started by this indicator here going green. We also see the port number that it's running on. And here we've got some scrolling text that tells us what the IP address is that we're running on. So that means if we have got a client, we can point the client to this particular IP address, and that's where our server is residing. It also shows us in Apple terms the interface that it's using and what type of interface that is. So in this case, it's a Wi-Fi interface, and that's where that's sitting. The window underneath here will show us any connections. So if we've got a client that's actually connected to it, we can see that. So if we connect the client, that client will show up. It'll show up where the client is coming from, what the client's port number is, and it's obviously connected to our interface here with that port number. You can see that that is currently in blue. Now when the client disconnects, that color, so the client is disconnected, that'll go grey, and after a little while it'll disappear. So just to show that again, a client connects, it's blue, a client disconnects, it's grey for a short period of time and then disappears. Okay, that's that part. Here we have got the ability to mute the server. So that means when a request is coming in, the server is not going to send a reply. So that's a complete muting. There we've got an access indicator. We'll show that later what the access indicator does, but it basically tells us whenever Modbus memory is getting accessed by a server, by a client. And then we've got the ability to look at exceptions. So this is when we're trying to do to generate errors. We've got the ability to look at exceptions here. Now here's an exception window that comes up. We'll go through that in another video to explain the details of those exceptions. For the time being, the important thing to know is that when that text here is read, it means you've got some active exceptions. So always make sure, if you want it just to work, that is grey and everything in there is unticked. Then we've got the data log window. Again, we'll go through that in a separate video, but just for a quick demonstration, here's a data log window that comes up. So that data log window can be switched on and off with this button here, or via the menu as well. Now finally, the core of the TCP server is the different memories. Modbus supports a coil memory, which is classically outputs, and input memories, and they're digital outputs, so they're only a 0 or 1. We have got a digital input, 0 or 1. We've got a holding register. So a holding register is a multi-bit register. In Modbus terms, a single register is 16 bits wide. And we have an input register as well. So these are classically used for analog inputs, for example, to be read in the classic Modbus system. Holding registers are probably the most popular. And we've got these two buttons here, and they allow us to add a register. So if we want to add a register, we can put the register in here, and it'll automatically add some. But we can now go and we can click in here, and we can change that register address. Let's say that's register 10, and let's say that one here is register 11. We can put in any text that we like here. My register 11, so we can change that, and of course naturally we can also change the value of each of those registers. They're created with a default value that we've seen defined in our preferences. So we might just set that one here to 11 and set that one here to 22. And these are the values that those registers contain. Right, now a very simple test here. We can use, and in this case I'm just using our Modbus client to simulate what we're doing here. So you would of course have a client that's probably from something else other than a piece of software. But we create a connection here, so it's now connected. We can see that. I'm requesting 2 items here, and if I have a look at that definition, that's address 1, a quantity of 2 registers. So these are 2 registers at address 1 and respectively address 2. So let's just go and make that request. We do a request, and we can see that lit up. If you had a quick look, that lit up in blue, which means it was a read request. And as you can see now, those registers are automatically added because that's what we have selected for those registers to be added to it, and those values have come across. So if we change our values in here and just make them something different, 100 and 200, and we do another request, we can see that that's the data which is coming across to our TCP client. So we can also remove registers. We can highlight that, and we can click the minus button, and that'll remove registers. And as you can see, these are holding registers, coil registers, input registers, input single bit memory and input multi-bit memory. They've got nothing in it, but we can also create some in here as well. And then as we click between the different memory types, we can see what we've got there. All right. Now the functionality that is a bit new to this is we have got the ability here to actually select the type of display that we want. So I can display that as a decimal, as an unsigned, or as an ASCII, as a binary, an octal, or a hexadecimal. And hexadecimal is fairly widely used and comes in quite handy. So if we go to that and go hexadecimal, so we've now got those values visible in hexadecimal. But the other thing that we can do, and let's just add some more addresses to that. The other thing that we can do is let's reset those to 0, and you can see these are hexadecimal because I can see the 0x. These ones here haven't been configured, and that's, by the way, that's done with a right click. So if I right click or option click in the row, we will get this context menu, and the context menu allows us to change the display format for each individual item. We've also got the option of combining registers. So sometimes values are greater than 16 bits, and if that's the case, then and you need to simulate a value that's greater than 16 bits, we've got the ability to make this a 32-bit value. So now that value is 32 bits, which means it takes into account this register, the address 1, plus the register following it, which is 2. Together they make up the 32 bits. If we expand that a little bit, and we can see when we look at that, well, we've only got 0 in there, so it's not going to do much for us. But let's put a big hexadecimal value in there. Let's put in there. So that would normally be the limit of a single register, and that's the limit of a 32-bit register. So if we have a 32-bit register in there, and we change our format to binary, we can see there's a B on the end. We can see there's 32 bits now located in that. I can switch that back to 16-bit, and then naturally we have got the display formats, and these are split up again. The other thing that occurs, and let's just make a different value in here, A1, A2, and let's make this one here B1, B2. Now when we combine these into a 32-bit, we can see the combination A1, A2, B1, B2. However, when I hover over this register here, I can see that the value in this register is B1, B2, and the value in this register is A1, A2. So whilst we're displaying it as a combined value, of course the registers individually contain those values, and that applies to any of those combinations that we have. So that's a great flexibility that we have got with this system. So let's just change that back to 0, and let's make that a 64-bit. And now with the 64-bit, you can see that that takes up 4 registers. So therefore, these registers here are all part of that one that is being displayed here. We can see the individual values, but if we put something else in here, we can obviously have up to 64 bits displayed in that value, and we've got the various formats. Now let's switch that all back to 16 bits. And we have also got the ability to define a float value. Now float values are floating point decimals, 32-bit by their nature, and they use the IEEE notation. So then we can represent things like 123.456, and that's the value in flotation format. but you can see the raw value is in this register E979 and in this register 42F6. So we've now got some very useful ways of displaying the information that we've got available. So you will be able to change all that when you change it back to decimal, for example. It no longer makes any sense, hexadecimal, but float 32, that does make sense. Okay, let's change that back to different formats. So that's a good functionality that we've got available here. We've also got the ability, of course, to actually save that configuration. So if we go save here, we have got the ability to save that as test1. I'll call it an AA test1, and we have now saved that configuration. Now, if we start up Modbus TCP Server again, and we decide that we want that configuration back, we can go into our recent files or open files. And here we go, all of that is back. So that's the short introduction to Modbus TCP Server. If you have any questions, please leave that in the comments below, or otherwise contact us directly at support@ephux.com, and have fun using Modbus TCP Server, and keep a lookout for the next videos. There's a couple more videos, one about exceptions and one about the data log. Keep an eye out for that. I'll post a link down below. Thank you for watching.